Have you ever wondered what happens when a massive object collapses under its own gravity? What if the object is so dense and compact that not even light can escape its gravitational pull? Welcome to the mysterious world of black holes, where the laws of physics as we know them break down and the space-time fabric becomes warped beyond recognition. In this documentary, we will explore what black holes are, how they form, and what their properties and effects are. To understand what black holes are, we need to understand the nature of gravity, the fundamental force that governs the motion of massive objects in space. According to Einstein's general theory of relativity, gravity is not a force that acts instantaneously across space, but a curvature of spacetime caused by the presence of mass or energy. The more mass or energy an object has, the stronger its gravity and the more it warps the spacetime around it. When a massive object collapses under its own gravity, the spacetime curvature becomes so steep that it forms a singularity, a point of infinite density and curvature where the laws of physics break down. Around the singularity, there is a region called the event horizon, beyond which nothing, not even light, can escape the gravitational pull of the black hole. The event horizon is the boundary of the black hole, beyond which the spacetime is so warped that it becomes a one-way street leading to the singularity. Black holes can form in several ways, depending on the mass and initial conditions of the collapsing object. The most common type of black hole is the stellar black hole, which forms from the collapse of a massive star at the end of its life. When a star exhausts its nuclear fuel, it can no longer produce enough radiation pressure to balance its gravitational collapse. The core of the star shrinks and heats up, triggering a runaway fusion process that produces heavier and heavier elements until the core becomes a dense ball of neutrons. If the core mass is above a critical threshold of about 3 solar masses, it will continue to collapse under its own gravity and form a black hole. As the star collapses, its outer layers are blown away in a supernova explosion that can shine brighter than an entire galaxy for a short period of time. The remaining core, now a black hole, can have a mass of a few solar masses to tens of solar masses, depending on the initial mass of the progenitor star. Stellar black holes are the most common type of black hole and are thought to exist in the hundreds of millions in our Milky Way galaxy alone. Another type of black hole is the intermediate mass black hole, which is thought to form from the runaway merger of several smaller black holes or from the direct collapse of a massive gas cloud. Intermediate mass black holes have masses ranging from hundreds to thousands of solar masses and are rare but important for understanding the growth of supermassive black holes. The third type of black hole is the supermassive black hole, which resides at the centers of most galaxies, including our own Milky Way. Supermassive black holes have masses ranging from millions to billions of solar masses, and are thought to have formed through a combination of mergers of smaller black holes and the accretion of gas and stars over cosmic time. The formation and growth of supermassive black holes are still not fully understood and are a subject of active research in astrophysics. Black holes have several fascinating properties and effects that make them both mysterious and dangerous objects in the universe. For one, black holes are completely black, meaning they do not emit any light or radiation of their own, except for the Hawking radiation that is predicted to be emitted from the event horizon due to quantum effects. However, black holes can be detected indirectly through their gravitational effects on nearby matter. For example, if a black hole is in a binary system with a normal star, the gravitational pull of the black hole can distort the shape of the star and cause it to emit X-rays, which can be detected by telescopes. Another property of black holes is that they have a size proportional to their mass, but a density that increases as their size decreases. This means that the smaller the black hole, the denser and more powerful its gravitational field, and the more destructive its tidal forces. If an object gets too close to a black hole, it can be stretched and torn apart by the tidal forces, a process known as spaghettification. Black holes can also be sources of powerful jets of plasma that shoot out from their poles at relativistic speeds, creating spectacular astrophysical phenomena such as quasars, blazars, and gamma-ray bursts. The jets are thought to be powered by the accretion of matter onto the black hole, which heats up and accelerates the charged particles in the surrounding disk. In conclusion, black holes are some of the most fascinating and mysterious objects in the universe, with properties and effects that challenge our understanding of the laws of physics. From the formation of stellar black holes to the growth of supermassive black holes play a crucial role in shaping the structure and evolution of galaxies. Studying black holes can also help us test the limits of our theories of gravity and quantum mechanics, and provide insights into the ultimate fate of the universe. As we continue to explore and discover more about the universe, black holes will undoubtedly remain one of the most intriguing and awe-inspiring phenomena that we encounter.